A particular type of statement that we deal with are what we call quantified statements. And a quantified statement is one that includes the quantifier all, some, or none. So as a couple examples, statements like P, all pigs can fly, or Q, some buildings have basements, these are what we call quantified statements. Again, they're declarative statements, declarative sentences rather, they're either true or false, not both, but in particular, they're quantified. We're either talking about all objects can do something, or some objects have some property, or none objects can do or have a certain property. Now, quantified statements can be kind of tricky to work with. In particular, it can be tricky to negate them, and we're going to spend some time talking about how to negate our quantified statements. But for starters, just let's take a look at a statement and determine, is that true? So let P be the statement, some cars are automobiles. The question is P true? And the short answer is yes, and that's the correct answer, and probably your first response when thinking about that question. But if you think about it too much, you may sort of trick yourself here. So the statement is some cars are automobiles, and you could make the argument that all cars are automobiles. And in that case, then the statement some cars are automobiles isn't actually correct. We should say all cars are automobiles. Now, maybe you disagree with that. Maybe there are some cars that you don't consider to be automobiles, but let's just follow that line of logic. Suppose you do believe that all cars are automobiles. That would not make the some statement false. Okay? Even if a statement is universally true, for example, all A are B, all cars are automobiles, or all chihuahuas are dogs, or something like that. Even if a statement is universally true, then the some statement is also true. To say some cars are automobiles truly means that at least one car is an automobile. And for that reason, the word some is a little strange in the logical sense. Some means at least one. So that's another thing that can be misleading. Even if the statement is only true for one particular case, some is still an accurate word to use. So for example, if you could think of a statement that is only true in one case, and you said that it is true sometimes, then that is still true. It's true sometimes. The issue is when we say some in everyday speech, we tend to think of it as being a plural word, right? When we say some things are happening, we're referring to multiples. But logically, some means at least one. So it could just mean one. It could also mean all. So possibly all. Okay? So whether you believe that all cars are automobiles, or there is only one car that's an automobile, let's say you're a particularly fanatical about Fords and you think Ford is the only true automobile. In either of those cases, the statement some cars are automobiles are still true. Fortunately, the statement is also objectively true because, like I said, our statements really aren't determined by opinion. Okay, let's talk about negating statements that are quantified. So I have here 4 quantified statements, all using the different quantifiers. All dogs have fur, some dogs have fur, some dogs do not have fur, and no dogs have fur. And I want to figure out the negation for each. And so let's start with the statement, all dogs have fur. Now, at first glance, let's get rid of that. Okay, so at first glance, it might be tempting to say the negation of all dogs have fur is that no dogs have fur. Okay? Now, again, this is not correct, but this is the type of thing that stems from thinking negations purely in terms of opposites. The opposite of the statement all dogs have fur, you could make the argument for saying its opposite is no dogs have fur. But again, negations aren't truly opposites. They're statements that have opposite truth values. And if we think of these two statements, let's think of the case where maybe 90% of dogs have fur. Okay, so 9 out of every 10 dogs have fur. The statement P would then be false, because it's not true that all dogs have fur. There's the 10% that do not. The statement not P would also be false. It's not true that no dogs have fur, because 90% of them do. So in that case, where 90% of dogs have fur, which I would wager is probably close to the truth, both of these statements are false, which means they're not negations of one another. Instead, To negate this statement, what we should say, not P, is some dogs do not have fur. Okay, so let's think of the possibilities here. If every single dog in the world has fur, then the statement P, all dogs have fur, is true, and the statement not P, some dogs do not have fur, that would have to be false, right? Because we just said all the dogs have fur. So the statement that some dogs do not must then be false. Suppose no dogs had fur. Then the statement P, all dogs have fur, would certainly be true, and the statement, the statement P, all dogs have fur, would certainly be false, right? I just said no dogs have fur. And the statement not P, that some dogs do not have fur, that would then be true, right? Because some of them do not have fur. No, none of them do, so certainly some of them don't. So again, we have P and not P having opposite truth values in every possible case. And so negating quantifiers can be dangerous because, again, if you just try to replace the word all with none and say, well, they're opposites of one another, you get statements that don't always have opposite truth values. Okay, suppose we wanted to negate the statement, some dogs have fur. The negation in this case would be no dogs have fur. Okay, some dogs have fur is stating that at least one dog in the world has fur. The negation of that would be that there are no dogs that have fur. When forming negations of quantified statements, try to think of how you would refute the original statement. If I were to claim to you some dogs have fur, and you go, nuh-uh, and I go, prove it, how would you prove to me that it's not true that some dogs have fur? Well, what you would have to do is collect all the dogs in the world and go, look, none of them have fur, and therefore it is not true that some dogs have fur. Now, of course, that's impossible, but if we think of P, that's a little bit easier to wrap our heads around, right? If I say to you, all dogs have fur, and you say, again, nuh-uh, and I say, prove it, then all you gotta do is bring me a dog that does not have fur, and say, see, some dogs do not have fur. All right, let's negate the other two options here. Are some dogs do not have fur? The negation of are in this case. So it is not true that some dogs do not have fur. And if it's not true that some do not have fur, then that means all dogs do have fur. So all dogs do have fur. Notice that statement looks familiar, right? That's P from before. And we said when P was the statement, all dogs have fur, then its negation was the statement, some dogs do not have fur. And therefore, the negation of R, some dogs do not have fur, must have been P, not R. All dogs do have fur. This leads us to the fact that the negation of a negation takes us back to the original statement, which is absolutely true, and we'll write that as a property. All right, but one more quick example. S, no dogs have fur. So not S, again, if I tell you no dogs have fur, and you want to prove me wrong, you would have to show me at least one dog that does have fur. In other words, you'd have to say, some dogs do. So its negation would be, some dogs have fur. Okay, so a couple things that we got from this. First of all, as a property, the negation of a statement P takes us back to P itself. Basically, this is our double negative property. Not P is the same thing as P. And this is true for all statements P. The other thing I want to write out is we saw that all was negated by some do not, and then none was negated by some do. And sometimes we write this out in this manner as a way of remembering those relationships between our quantifiers and their negations. Let me actually rewrite. This part got a little messy, so let's rewrite this. Okay, so our negation of none was that some do. Our negation of all was that some do not. And here's a little quick snippet that maybe you can try to use to help you remember. But at the end of the day, as with many things in logic, the way we negated these quantifiers here shouldn't necessarily be something you memorize, and more think about why it makes sense. And again, to go back to, for example, that first case of all dogs have fur, if you wanted to disprove that statement, then your job would be to find a single dog that does not have fur. And so not P should then be that some dogs do not have fur, and so on.